Okay, Newton's first law of motion. Newton's first law of motion is basically like this. Let's say I have a bike right here. And we got Mr. Man over here. He's thinking, huh, how does this bike have inertia right now? Well, as the law states, when an object is not moving, it's probably not going to move. But let's say it was moving. Mr. Man is now like, hmm, how does this have inertia? Well, when an object is moving, it has a tendency to move and to not stop unless acted on by an outside force, like this wall right here. Oh no. Splat. Oh, that's gotta hurt. Newton's second law is force equals mass times acceleration. And basically, what this equation means is it is a bypass of inertia. It helps break inertia because inertia, well, they're very closely related. These two concepts are very closely related because inertia is either it happens or it doesn't, and when it does, it keeps on happening. This is what makes it happen. Now, let's put this into perspective. Let's say I have a bike, right? And we got Mr. Man back at it again. And he's wondering, you know, hmm, you know, this bike is, let's say, 10,000 kilograms. That's the mass. And let's say I want to move it 6 meters a second squared. That would be the acceleration. And so, to get the force needed to push this 10,000 kilogram bicycle 6 meters a second, we just have to multiply it. And with some simple math, we can conclude that the force needed to push this 10,000 kilogram bicycle 6 meters a second squared is 60,000 newtons. 60,000 newtons to move a 10,000 kilogram bicycle at 6 meters a second. Light work for me, you know. But we could also do it the inverse way, you know. Say we only know the force and the mass. Okay. Divide the force by the mass. You get 6 meters a second. Now let's say we only have the acceleration and the force. Okay. Force divided by acceleration, 10,000 kilograms. That's how heavy this bicycle is. Very simple. Very easy to understand. Now for Newton's third law of motion. Every action has an equal and opposite reaction. Let's explain this with another bike. Okay, so let's say we're on planet Earth, and so is the bike, as well as Mr. Man, who is riding on the bike. Now, while Mr. Man rides the bike and he pedals with all his might against the earth, he's wondering, how does every action have an equal reaction on a bike? Now hold on, let me explain it to you. Whenever he moves the bike, the wheels, they push down on the bike, they push down on the earth every time they come in contact with the ground. And the ground pushes right back up when the other tire comes right back out. Now, the earth doesn't move a lot since your bicycle is so tiny and produces such little force against this big earth. It doesn't move. But it moves you. It moves you. It equates the same force that you put on the earth back onto you, allowing you to ride your bicycle all around the earth and back.